Good morning. I am Prabhu Bedmarat, Assistant Professor, Department of CSC, PLD Engineering College, Bijapur. In this video, I am going to discuss about chi-square goodness of fit test for exponential distribution. Yes, as we know already, this flowchart shows the development steps of useful model of input data. So we are going to apply the chi-square goodness of fit test at fourth step. So here the distribution we are going to assume is exponential. In previous video, we have solved a problem by considering Poisson distribution. Yes, this table shows the parameter estimator. So here we consider the parameter estimator for exponential distribution is, that is lambda. So the lambda is calculated by, that is estimator lambda, this is equal to 1 divided by x bar, nothing but x bar is nothing but sample mean. Yes, let us consider a problem statement. So chi-square test for exponential distribution, so where all the probabilities are what here equal. So the problem statement is apply chi-square goodness of fit test for exponential distribution for below given data by considering alpha is equal to 0.05, right. So this data they have given. For this data we have to apply chi-square goodness of fit test. So here they have asked us to consider the distribution is what here exponential. Okay, so the solution is the given data is what here exponentially distributed. The given data is exponentially distributed, right, and the size of the data is how much here, that is 50. So if we count all the data, so we have total 50, right, and the level of the significance, that is alpha is equal to 0.05. So according to the problem statement, the given data is what here exponentially distributed. So the parameter estimator for exponential distribution is given by lambda cap equal to 1 divided by x bar. So this is obtained from what here, the table. So where x bar is equal to what here, sample mean of a given data. So the sample mean is calculated using following equation. The above given data is what here, raw data. So the data is not grouped into frequency, or it is not grouped into what here, frequency intervals. So therefore, so which equation we will use for finding the sample mean, that is x bar equal to summation I equal to 1 to n xi divided by what here, n, right. So after adding all these data, so we have to add all these data, right. After adding all these data, next what we do, the value is divided by the total size of the data. So the total size of the data is how much here, 50. So we will get the final value, that is 11.89. The 11.89 is what here, sample mean, because the given data was what here, raw, and it was discrete, right. So this is the parameter estimation by considering the case 1, right. So after that we have to we will find what here, parameter estimator. So that is lambda cap equal to 1 divided by x bar. So that is 1 divided by 11.89, this is equal to 0.084 is the value of lambda cap, right. So once after finding the parameter estimator, the second step is what here, form a hypothesis. So H naught is nothing but what here, null hypothesis. The random variable is exponentially distributed. The H1 is the random variable is not exponentially distributed, right. After forming the hypothesis, The next step is find the endpoint for class intervals in order to perform chi-square test with intervals of equal probability, right. So, we have to identify which is a beginning point, which is a beginning range and which is a ending range, that is called as what here endpoints, right. So, the number of the class intervals is given by, that is n divided by 5. So, which is less than or equal to what here n divided by 5. So, this is given by the value of n is 50, that is divided by 5 equal to what here 10. So, we can have intervals for solving this problem, that is 7, 8 or 10, any value we can take here. So, let us consider the value of interval is how much here 8. So, we shall consider 8 intervals which is less than or equal to what here n divided by 5, right. So, the probability of each interval is given by what here p equal to 1 divided by 8. So, why we have taken 8 here? So, that is this is the size of the class interval. So, therefore, the probability in each class interval is given by 1 divided by 8, that is equal to 0.125. So, this is what here the value of p. Okay. So, next what we do, we will find out end point for each class interval for from the CDF of exponential distribution. So, we have to use what here CDF. CDF means what here cumulative distribution density function to find out end point for each interval. So, this particular equation will be used. So, we are going to substitute the value of lambda in this equation, right. So, lambda is nothing but what here the parameter estimator value, and 1 minus IP means what here I value is what here nothing but interval value, and P is nothing but that is 0.125, right. So, just now we have computed. So, this is what here P value, okay. And yes. So, next what we do, we will calculate the first end point, okay. So, the first the beginning will be what here 0, it will start from the 0. The first end point is given by, that is minus 1 divided by lambda value is what here 0.084 ln 1 minus 1 into 0.125. So, we get the first end point as what here 1.590. This is what here second end point. So, we will calculate second end point, third, fourth and so on up to what here last value, that is how many class intervals we have, that is 8 class intervals. So, therefore, whenever the k value is 8, we get so it is considered as what here last class interval as what here infinity. So, all these are what here the different end points for the class intervals, right. So, after finding the class intervals end points for class intervals, so we will apply the chi-square goodness of fit test, right. So, the first column is what here the class interval, so which starts from 0 and the end point is what here 1.590, okay. So, here the square bracket indicates you have to consider 0 and the parenthesis indicates you should not consider 1.59. So, within this range whatever the numbers which falls, so those numbers you have to consider. Suppose if the number is in a data that is 1.590 is there, then that should not be considered in first interval, right. So, here square bracket is what here starting point and parenthesis is nothing but what here ending point, right. So, you have to consider a data between 0 to 1.590 except 1.590, right, and all these are what here different class intervals, right. So, once after forming all these class intervals, we have to observe the data, right. So, you have to observe the given data, right. So, how many the data which is falling in first interval, how many the data, how many values which are falling in second interval, how many values which are falling in third interval, so on. right. So after observing the given raw data, right, so we got to know that 19 values are present in first intervals, 10 values are present in second class interval, 3 values are present in third class interval, and so on. In last class interval we have a values 6. So this is what here observed frequency, right. So after observing a given data, we have concluded that 19 values are present in first interval, 10 values are present in second interval, so on, and 6 values are present in last interval, right. So next is what here expected frequency. So the expected frequency is nothing but it is given by ei equal to n divided by k, right. So ei equal to n divided by k, so the value of n is 50 and the value of k is 8, because 8 intervals we have. So what is the expected frequency in each class interval? That is 6.25, right. So write down 6.25 expected value for each class interval, because equal probability we have, right. So after that what we do, we will find out. So here no grouping and nothing will be done with adjacent expected frequency values, right. So after that we will find out OI minus EI bracket square divided by EI. So the first value for first class interval is what here 26.01, and for second class interval 2.25, so on, and the last class interval is having a value 0.01. So after finding the individual values for class intervals, add all these values, so we get 39.96 total value. So this is called as what here the chi-square statistic value. So this chi-square statistic value is compared with the critical value. So the critical value is given by k minus s minus 1. So where k is nothing but what here number of class intervals, s is nothing but the parameters, how many parameters we are finding. So in exponential distribution we are finding only one parameter, that is what here lambda cap, therefore s value is 1. So it is given by 8 minus 1 equal to 6. So next what we do, we will find a critical value by using what here this is 6 and level of significance, that is chi-square 0.05 comma 6 equal to 12.6 we get. So this 12.6 is compared with the computed statistic value. The computed statistic value is what here greater than the tabulated value. So therefore the null hypothesis is what here rejected, right. Thank you. Please subscribe to my YouTube channel for more videos on system modeling and simulation.